So I have never done this. I went back through all of the prompt guides I've written over the last year plus, and I went through them, I collated them, I pulled them together, and I'm putting it into a comprehensive prompting course. But that's not all. I'm also separating it out so that it's got a really easy beginner's pathway into prompting. I'm going to lay out the first steps of that here in the video. Then a more advanced guide for when you're ready. And for folks that want to jump right to it, there's lots there. So this video is going to be very simple. We're going to go through the 4 moves that I want to sort of call out as the heart of prompting if you're still sort of trying to wrap your mind around what prompting is and why it matters. And then in the second part of the video, I'm going to give a little teaser trailer to the folks who are interested in advanced prompting techniques. And I'm going to talk about the patterns that I uncovered digging through hundreds of pages of prompting notes and guides that I have written over the last few months. What is it that stands out? What is it that's consistent? I found some really interesting things. So let's start with the beginner-friendly, accessible moves. 4 big moves. The big idea here is very simple. Instead of thinking of having a casual chat with an artificial intelligence, instead of thinking of just chatting with ChatGPT, I want you to think of it like you are briefing a contractor on exactly what you need. And you have 4 simple moves to do that. And this is actually, it maps really well to talking with a contractor. So you will get more consistent and useful results if you start with, for example, move 1. Tell your contractor, tell the AI what shape you want the deliverable, the thing it's going to write, to be in. Think of it like ordering at a restaurant. If you are not specific about what you want on the plate, if you don't say, hey, I don't want pastrami on the sandwich, well, you're going to get pastrami on the sandwich. So instead of saying, write something about X, tell the AI exactly what format you need. As an example of the kind of output shape that you can request, give me 1 paragraph between 110 and 130 words. I don't want any headings. It'll do it. Write exactly 5 bullet points, 1 sentence each. It'll do it. Create a simple 5-row comparison table. It'll do it. Make a checklist with only 6 items. You get the idea. You can be extremely specific, and this is actually a way to contain some of the more annoying response patterns that some of these AIs have. So for example, if you're tired of Claude telling you all the time how right you are and absolutely, you can just say, no LLM bumpers, go away. I just want your response. If you are tired of ChatGPT-5 writing super long responses, you can say, you got to give me the answer in 150 words or less. There are ways you can have more control here than you might think. Move 2. Give just enough context to your contractor or AI, not too much. This is like giving someone a recipe with all the ingredients they need and not too much. It's basically like a HelloFresh box if you've ever used it. It ships you the recipe and it ships you all the ingredients. Not any more, just the ingredients you need. Tell the chat, tell the AI to use only the specific facts that you are providing. Label them so that you can track where they came from if you really want to be sure that it got it right, right? So for example, if you were trying to get it to generate a response that's really clean and clear, you can say, here are some facts. Fact 1, our customer churn increased from 3% to 5% last quarter. Fact 2, most of our cancellations are from small accounts. Fact 3, our competitor just launched a cheaper monthly plan. Use only these facts. If something isn't covered here, please say unknown instead of guessing. This is helpful because you are less likely, not guaranteed, not foolproof, but you are less likely to have the chat, to have the AI make things up when you explicitly tell it that it has space to say unknown. There are lots of other ways to do this that I've suggested in the past. You can say inference as a label. You can suggest that it ask you questions instead of trying to make stuff up. Really, your choice there depends on the degree to which you want to give it more information to fill in those gaps versus you are giving it all it has, and it has to make the best assessment it can based on the information because that's all you got. And so you have to decide, like, how much information are you giving it? How much clarification do you want to offer it as a chance? Fundamentally, though, the idea is Give it the context it needs. Don't give it too much. If you want to be really clear about what's in the box, you can label that context. You don't have to. You can also just list the facts and say, these are facts. I want you to use these facts. Please do not guess. Please use another alternative method, because just saying do not guess, the model wants to be complete and helpful. So you have to sort of give it another way to be complete and helpful. And so saying label it unknown, that would be much more helpful, is a way to sort of let the model know to like track into that helpfulness vector that it has that's very strong. Okay, move number 3. Give your contractor or AI a simple behind the scenes plan. It's giving someone driving directions. It's telling them the route, but you don't need them to narrate every turn. And so you can actually suggest to the AI, these are some steps you can take, but you don't have to tell me about them. And that gives the AI some guidance on the tool calling, some guidance on the process it uses that is actually very helpful. So as an example, silently follow these steps. List the options, compare them, recommend only one, then show me the final comparison. In your head, prioritize by importance, add time estimates, assign owners, just show me the final agenda. You see how these are slightly different wordings, but you see the same idea behind them? You don't actually need to see the thinking process here. The whole like, please show me your thinking was an artifact of a pre-reasoning model era. We have reasoning models now. They will do reasoning. All you're doing is giving them some railroad tracks to guide them on that reasoning process and keep them moving in the direction you want. And that's helpful. So by the way, if the AI comes back and it shows you the thinking process and you find that unhelpful, you can just say, you know what, please don't show me the plan, just show me the result. And if it gets complicated and it comes back with a really long answer, that's either you didn't specify the result, or you can say, you know what, please keep your internal thinking to a shorter timeline, right? I don't have time forever. And this is something that we're seeing more and more in some of these interfaces that are coming out. Like if you look at Perplexity, you can click get the answer now. Very similar idea. You basically are telling it, cut short whatever you're doing and come back with a response, because I actually don't care that much about how in-depth your thinking is for this problem. And you as the human get to decide that. You get to say, yeah, I don't care, right? I don't care that much. And then this is a really interesting one. If you go through this whole thing, do the behind the scenes plan, right? The silent plan, and there's no clear conclusion, just end with your best recommendation and why. Because sometimes it's going to come through and you have to, again, give the model some help to be helpful. It wants to be helpful. Give it a sense of what to do in that ambiguous situation. Pick the best one. Tell me why. Okay, move 4. It is helpful to add a quick quality check, even in a short prompt. It's like having the model proofread itself a little bit before it comes back to you. It's like asking the contractor to check their work. Here's some examples of how to phrase it. Before showing me your response, hey, can you check, are there actually 5 bullets? If not, fix it. Verify every claim has a fact number, or verify each claim is based on the facts I gave you, or that it says unknown. Confirm that this paragraph is between 110 and 130 words. Check your work. Now, you might think, well, those are really silly examples you're giving me, Nate. But they're memorable, and you can use them however you want. You can specify the output shape that you want. You can specify how to check. You don't have to check the word length if that's not important to you. You can check for content and topics. The point is, ask for a check. It can help the model to do a second pass and address formatting issues. It can help address hallucinations and mitigate them to some extent. It can help with missing elements. It can help with incorrect length. It can help with complexity issues if it's too complicated. You just have to ask it to check its work in line with the original goal that you gave it. So let's look at some complete examples. So here's 3 complete examples. You have an email outline, and all you're doing is you're saying, I want you to outline an email to, and you can insert the audience. You have the topic. I want you to actually format this as an email with 5 bullets, and you're very clear about what's in here, right? There's a hook to this. There's why it matters. There's 2 points and an ask. That's 5 bullets. It knows how much it has. And you want to check it that if it doesn't have 5 bullets, it has to fix it. You can get an explainer prompt that works this way too, right? The task is to explain whatever concept. Maybe it's LLM token architecture, right? Explain it as if it's to a smart 12-year-old. You have 3 parts with headings: what it is, an example, and gotchas or misunderstandings. You have limits. It has to be less than 140 words. And check that all 3 headings are present, because you want to make sure that that's what you want to check, right? That all 3 of those are present. A decision helper. Compare 4 options for this decision I'm facing. Compare on price, setup, learning curve, ongoing effort. You could really define it any way you want. This is the shape of the output. It's a 4-row table. And end with your recommendation. 1 sentence pick and why. Please check that the table has rows and columns. Pretty intuitive, right? And one of the things that you'll notice is in each of these, I am giving the model space to process how it wants. That is not always true. It does underline one of the core principles here. If you are communicating your intent really, really clearly, you can choose to drop some of these. You can choose to say, you know what, the shape doesn't matter. You can choose to say, I don't care about the check. And that depends on you deciding what matters and what doesn't for the work that you're trying to do. Let me give you a few more examples. Now, these examples are just a little bit more advanced, and I want you to notice that we've decided to be more specific. We've decided to have some silent process here. An incident snapshot. Let's say something goes wrong at work, right? You want to describe what happened and what went wrong. You include some notes here that you label. You specify what the shape of the output is for executives. You say, this is the process, because you really do care that it actually looks through the facts, it quantifies the scope. These are things you need it to do to know that it looked at all the notes. And then you specify that there is an owner, right? It has to check that there's an owner. It has to be clear if there's something that's unknown, so that you're not over claiming. What you're trying to do here is essentially take a fairly complex, normally human task and actually put it into a short prompt that you can get a very reliable initial pass on for a high stakes action. So it makes sense that each of these things actually is specified. In the same way, let's say you want an action plan from a high value meeting, right? You have a shape, you have a checklist with boxes that you want for your action plan, you have notes that you've included. Your silent process is really around extracting the tasks, ranking them, making sure that you get the right tasks. And you want to make sure that you have exactly 7 boxes and that every line has an owner and a due date, and that you're not duplicating tasks. And so that's what you want to check. You get the idea here, right? You can do a more complex assessment for higher value tasks. And you can see here the example from the title for a video post. It's very similar. I won't go into it in depth. The point is, this format is flexible enough to get somewhat more specific with a higher value task, or it can be lighter, like I showed you initially. Now, we are going to do a little bit of a jump forward, and we're going to talk about some of the prompting patterns that I learned when I was digging through my own notes and exploring how prompting has evolved in 2025. These are things that are non-obvious that I don't see discussed online. So hold on to your hats. All right. What are the non-obvious, under-discussed principles that came out to me as I sat here and I was putting together these guides, this in-depth prompting guide that I've been putting together for you? Number 1, the unit of design. We think of it as the prompt, but the more I stared at it, the unit of design is the pipeline, not the prompt. So we think about prompts as like things we tell the chatbot, but really, even if you're in the chatbot, the prompt is living inside a structure. It's living inside an architecture. So there's things like retrieval, or maybe tool calls, or memory, or evaluation. When you treat each of these as isolated artifacts, the reliability of the prompt falls apart. If you build the pipeline first, then you can write prompts to fit. And so a lot of my work, when I'm sort of building prompts, helping people move through from beginner to intermediate to advanced stages of prompting, is really understanding the pipeline they're operating in. And for many people, the default pipeline is just the ChatGPT user interface. It's all defined, right? Whatever you have, it's in the interface there. If you're building your own, all of that stuff is up for dialing and adjustment, right? And in those circumstances, you are designing the prompt after you design the pipeline. The pipeline is the first thing you think about. And this is part of what makes prompting so difficult to teach, because if I give you a prompt insight, it may work really well in a particular pipeline environment, but not as well in another one. So think about your pipeline as a first-class object. Second thing that came out to me, context is a supply chain with trust boundaries. So every token that you feed the model comes from somewhere, even in a short prompt. User input, docs, the web. It is really important that you think of that context as having trust boundaries if you care about things like safety, security, prompt injection, if you care, which you should, by the way, if you care about reliability and avoiding hallucinated responses or inaccurate responses, the way you do that is by making sure that you understand that you have trusted resources, somewhat less trusted resources, and unsafe or untrusted resources. Now, if you're building a complex pipeline, you may actually directly label that stuff. If you're building a high value prompt, you may directly label that. I do that sometimes. I'm like, these notes are very reliable. These notes are not reliable, right? If you are in the middle of a casual prompt, you may actually just label it in the middle of the chat. But regardless, you need to recognize that when you are working with context, you're basically loading in a supply chain of tokens. And the more you can indicate, trust this, don't trust this, the more likely you are to get higher quality, higher reliability responses out of your model. Third one, I have mentioned this before. It has been a while. Contracts really matter. And contracts are basically a fancy way of saying format matters and prose comes second. And so if you are going to be specific about the outputs that you expect, if you are going to frame an interaction as we are forming an agreement together, we are forming a contract together, that is going to go a long way because just as I said it in the first part of this video, you're working with a contractor. That's the mental model. You want to have a contract with your contractor and you want to make sure the outputs are specified. Now, some people go overboard here, and I have seen the hype around the internet where they say, well, JSON is the only way to prompt. And it's not well supported by the documentation. Certainly models can read JSON, but they can read lots of other things too. If anything, the way to think about it is that you want clarity. You want clarity on your expected format and outputs, and that in turn helps improve reliability because the model knows what you want. And so contracts are just a way of encoding your intent. And if you have a more complex pipeline, your contracts get suitably more complex. But this idea scales, right? Like all of these insights are designed to scale. One of my hypotheses, if you want a little sidebar from Nate, is that prompting is fractal. Like you have a simple version, but it's fractally related. It's essentially the same thing in miniature as a more advanced version of prompting. And a lot of these insights I found are fractal, they scale. Number 4, entropy is a design variable. I know, sit down, have some coffee. We're getting deep in here. So if you understand about prompting, you understand that you can shape things like temperature and top P, which if you're a beginner, you don't worry about. That's preset in ChatGPT. If you're more advanced, you can set that in the API, and it constrains the probability distribution. But you can also use constraints, you can use examples, you can use output schemas, and those further narrow the distribution, right? You're still shaping the distribution. So the larger insight here is that your entire goal is to shape the probability mass. That's what you're doing. With constraints, with examples, with context, with output schemas, with temperature, with top P, you're all shaping the probability mass. You are using entropy as a design variable. You're not just making it more creative. You're actually shaping the probability mass of the outcome. Now, that may seem really abstract, right? It may seem theoretical, but I think having correct mental models helps us to actually decide where to apply leverage. And this is definitely an advanced concept. But if you understand that temperature, top P, constraints, examples, outputs, all of that is related, it helps you to understand where to apply leverage in the system. Because you can say, well, the output schema is probably going to be more effective on probability mass here versus temperature because X or Y. So just take that, think about it, go for a walk, think about it some more, and it may start to click with troubleshooting advanced prompts. Number 5, scaffolding often matters more than just horsepower. So if you're in the API, you can just like burn tokens on stuff, and that can be helpful. But if you can give the model techniques, things that I cover in the advanced prompting guide that is sort of in the Substack here, like least to most, tree of thought, stepwise plans, you're essentially giving the model a way to reduce cognitive load. You're giving it something that helps it with error accumulation, and you're adding structure, right? You're giving it a scaffolding for how it thinks, and that scaffolding makes it more token efficient. And so the little meme that I keep in mind is that scaffolding beats horsepower. Have good scaffolding. And yeah, horsepower is inevitable, right? Like there's a reason we talk about burning tokens as a way to solve problems. But in a world where we need to be token efficient, which is especially true in production prompting environments, have good scaffolding. Scaffolding matters. And I definitely get into that in the advanced sort of prompting section. So if you want to dive in, there's a lot there. Number 6, shifting the distribution is enough to break your best prompt. So if prompts are tuned on a handful of examples, they will drift in the wild if they face a wild normed distribution, which is a fancy way of saying if you train your prompts and you say this prompt works well in the studio, in the environment, and then you release it into the wild and it's dealing with consumers and they're asking all kinds of things, it's going to break your best prompt. This is another way of saying I have seen the debates on evals. You absolutely need to take quality seriously in production. You need to have the ability to test it. You need to have the ability to monitor it. You need to have the ability to evaluate it and roll it back and version it and treat the prompt like code. The wild distribution is good enough to break the best prompt, and the way to address it is to treat prompts like production code that needs sustained investment to be optimized over time. You can't assume you can just release it and it tested well. And again, the mental model matters here. If you think about a wild distribution of everyone trying to sort of send queries against your chat bot, well, that's going to matter. Like that's going to break it. You can understand why that breaks it. And you can understand why that's different from a lab-grown distribution, which tends to have narrower tails. And that in turn can shape your evals. Your evals should push your distribution as wide as you can. Part of your goal is to get your lab-grown distribution to stretch and to actually be more effective. Number 7, model pluralism is a feature, not a bug. Different models really do have distinct personalities and strengths. You feel it more the more you work with them. It really, really matters that you not build your architectures assuming only one model, or assuming one model will do it all, or assuming that you only need one model for now, et cetera, et cetera. This is one of those things that marks the boundary between a beginner view of AI and a more advanced view of AI. The farther along you are in building sort of with AI, the more you recognize that you are building with multiple models, and people have like Claude and ChatGPT and Gemini for this and this, and they'll recite off the top of their head all the use cases they have and which models they use. And if you're building production pipelines, you'll know which versions of those models you're going to use and why. Model pluralism is not only a feature, it is the future. You should expect to have a pluralistic model environment. And the more advanced you are, the more models you're going to be using, not because you love complexity, but because you love efficiency, and you can pick the right model for the right task. Insight number 8. The farther you get with prompting, the more you recognize that economics are a first-class constraint. You know, Satya talked about dollar cost per token per watt as the equation for the next 10 years, and he was right. Token budgets matter, latency matters, fallback logic matters. The more you look at architectures, it's less about picking cool tools, and it's more about making sure that you have a reliable, scalable, efficient architecture. Thinking about how loads actually hit models, what models handle what loads, how models pass and make tool calls at scale, those all start to matter. What is the cost of the model making those choices? Why? Do we need it to make that choice? Is there a simpler way we can design this? This is actually one of the great examples where I see strong engineering instincts from humans handily beating LLMs at the moment. Humans are really good at designing efficiently engineered systems, and models tend to be good at adding complexity. And when you are trying to design a system that keeps economics in mind, you have to design for simplicity first. Number 9, governance beats heroics. Heroics are a fancy way of saying people are out in production and they're desperately trying to do their very best, and they're trying to write the best prompt by next Thursday, et cetera, et cetera. No, have good governance, have versioning. You can A/B test changes. You can evaluate with rubrics. You can log things. Your prompt library ends up being intellectual property. Manage it as if it was code. Govern it like it was code. And this is a different way of talking about the same thing I talked about earlier. Distribution shift will break your best prompt. That was really about how you care about testing and evaluating. This is really about the governance structure that keeps production prompts going. Governance beats heroics. Just like we say in engineering circles, don't play hero ball. If it is up to you to play hero ball to sustain this code in production, it's not good code. Similarly, if it's up to you to sustain this prompt in production, it's not a good prompt. You need good governance first. Number 10, safety gets designed in like at core. It's not added on. So constitutional system level rules, which I talked about in the advanced guide, refusal styles and how you handle it, how it handles ambiguity, how you address jailbreak attempts and prompt injection attacks, output moderations, that's all part of the spec, right? That's not an afterthought. You think about that from the beginning because you have to assume that models are unsafe by default. And the only way you make them safe is by designing them to be safe from the get-go. And so again, this is one of those things that really distinguishes advanced prompters from beginning prompters. Beginning prompters operating in a chatbot, the chatbot is pretty what we would call nerfed, right? It's like whatever ChatGPT gives you, whatever Claude gives you, you can bounce off those walls, but you're not going to get very far. If you're designing your own system, it's very different. You are responsible for all of that safety stuff, and you have to take it seriously. Number 11, memory is not a toggle. Memory is a product choice. Deciding what persists, where it's stored, how it's summarized and validated, what the model remembers. You have to assume that the context window is nothing. You have to assume that memory or statefulness is something you want to design into the architecture of the system, and context windows are just ways to generate a particular response. People who assume the context window or the model remembers is going to work, it's not going to work. Even if it's a very large context window, it is only useful for that response. Keep in mind, models are reinforcement learned. They're trained on basically single response patterns. Whatever you give it, the ideal response from that model is one. One. Now, some people will go longer, but this key idea explains why beginners are often surprised when they continue a chat and then they get 30, 40 turns in and the model seems to forget. That's just how it works, right? The product choice that ChatGPT has made and other model makers have made is to have like a rolling context window in certain situations. And so the model will keep talking and roll the context window and it will forget the initial thing. Now, Claude has made the choice not to do that, notably. Claude has decided they're just going to end the chat. That also frustrates people. There is no good answer here. The only way that people who build advanced prompt architectures get this to work is by deliberately architecting what is stored and what is summarized and validated and how it's retrieved. This is where we get into the discussion of RAG, right? Retrieval, augmented generation, other ways, chunking data, etc. Memory is a product choice. Don't assume memory is in the context window. The 12th and last insight, automated enforcement beats human vigilance. Do not trust that the model will follow your rules. Install automated checks. In larger systems, you actually have separate LLMs that are checking for specific elements of the output and then coming back. And they're cheaper, right? They're often dumber LLMs and they check for specific things. Is it in a bulleted format, right? Is it reflecting the style guide? Whatever it is, right? You want to make sure that you have automated enforcement checks because that beats the best human diligence. It beats the best human evals. The more you can build enforcement of the schema, enforcement of the output into the system, so it's just part of the system, you're not playing hero ball, it's just good engineering. And that's really where I want to leave you. So many of these insights, as I stared, and I'm not kidding, it was like 500 pages of like prompt stuff I've written. I've been pretty prolific. And I keep looking at this and I'm like, you know what? Really what we're doing is we are pulling so many of the principles of good software engineering forward, and we're talking about them in the context of artificial intelligence system design. And the principles are not new. Governance beats heroics. That's not new. Google knew that a long time ago. But we have different ways to apply it in the AI age. And people forget it because they think that you can just talk to the AI and make it do anything. So it's worth repeating. It's worth reiterating. So there you go. Those are the 12 things I noticed. I hope you dig in. I hope you enjoy the advanced guide. If you're still here listening to these 12, you probably want the advanced guide. It's like 100 and something pages. It's really in depth. I had fun. I basically took everything that I learned over the last 6 or 8 months, and people kept saying, Nate, 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 I'm tired of looking at all these guides. Can you just give me like one thing? This is the one thing. This is the one thing. This is the guide, right? Like this is the soup to nuts, A to Z complete guide for prompt engineering as it exists today in September 2025. I hope you enjoy it.